exponential equations, and change of base. Perhaps the most important reason for having logarithmic functions is to be able to solve exponential equations. So take a look at the following example. We have the number 25 raised to the power of 2x plus 1 is equal to the number 15. We would like to be able to know what is the number x that makes this equation true. This is an exponential equation because the variable is in the exponent. And we have not talked about how to solve these kinds of equations, except for the fact that we can do it quite easily when the bases are the same. So for example, if I say 9 is equal to 3 to the 2x, we know that 9 is 3 squared, and if that's equal to 3 to the 2x, since we now have a common base of 3, we would know that 2 is equal to 2x, or x would have to be equal to 1. But we can only do this because of the fact that 9 and 3 have a common base. But the numbers 25 and 15 do not have a common base. So how do we do this? Well, what we're going to do is take a logarithm of both sides, and you can use a common log or a natural log. So either log base 10 or log base e. Now, I like to use log base e for everything. So I am going to take the natural log of 25 to the 2x plus 1, and that must be equal to the natural log of 15. Now, the reason we do this is because now this power here, which is where x is located, can be brought down in front of the logarithm, right? That is a property of logarithms. So this gives us 2x plus 1, all multiplied by the natural log of 25, is equal to the natural log of 15. Now, from here to solve it, there's actually a couple of different ways that you could go about this. What I like to do, because in general this is a better practice, is I will multiply this out. So that's going to be 2x times the natural log of 25 plus, and then 1 times the natural log of 25. And that's equal to the natural log of 15. Keep in mind we are solving for x, so I'm going to subtract the natural log of 25 from both sides. It's the next step. So this gives us 2x natural log of 25 is equal to the natural log of 15 minus the natural log of 25. And then my final step to solve this is to simply divide both sides by 2, right? Because that's going to cancel the 2 here. And also by the natural log of 25. And that's going to cancel this out. And all we have left over on the left-hand side is x. And on the right-hand side, we have our exact answer. Okay, so this is the exact answer. So if they ask for that, this is what you would type in. But we are also going to give a 4 decimal place approximation. And take a look at how I plug that in. So we have the natural log of 15 minus the natural log of 25. Notice that we have to put parentheses around that whole thing, because the whole thing is divided by, and then this whole thing, 2 natural log of 25. So when we do that, we get an answer of approximately negative 0.0793. In our next question, how long does it take for $5,000 to double if it is deposited into an account that yields 5% interest compounded once per year? Okay, so we are referring to the formula A equals P times 1 plus R divided by N raised to the NT power. In this problem, our principal P is $5,000. Our interest rate R is 5%, which needs to be changed to 0.05. We are compounding once per year, so N equals 1. And the amount we wish to have in the future, if we're doubling our money, double 5,000 is $10,000. And then we want to know how long will this take. So we're going to plug all these numbers in. So for A here, we have 10,000. For P, we have 5,000. And then we have 1 plus 0.05 divided by 1 to the 1 times t. So this is 10,000, we can drop the dollar sign, equals 5,000. 1 plus 0.05 divided by 1 is 1.05, and then the power 1 times t is just t. Now I'm going to divide both sides by 5,000. So these will cancel out here, and then 10,000 divided by 5,000 is 2. So we have 2 equals 1.05 to the t power. Now I'm going to take the natural log of 2 and the natural log of 1.05 to the t. This allows us to bring the t down. And so we have natural log of 2 is equal to t times the natural log of 1.05. And finally, to solve for t, I'm just going to divide by the natural log of 1.05. These will cancel out, and we get t is equal to the natural log of 2 divided by the natural log of 1.05. And I'm just going to plug that into a calculator to see what we get. And this is approximately 14.2. So how long does it take to double your money in this situation? 14.2 years. Next, we have what is known as the change of base formula. So if a and b are both positive numbers, not equal to 1, and if x is a positive number, then the log base a of x can be changed to the log base b of x divided by the log base b of a. So if you have a base a and you want to change it to some other base b, this is the formula for doing that. Now, why would we want to change the base? We'll take the following example here. What is the log base 8 of 24? Well, we don't know because most calculators don't have a button for the log base 8. So what I can do is I can change the base to whatever base I want. Now, the base you're going to want to change it to is either 10 or e, because those are the logarithms that you have on your calculator. So I can rewrite this as log base 10 of 24 divided by log base 10 of 8, or I can write it as the natural log of 24 divided by the natural log of 8. And now we just need to plug this in to get the answer. And I plugged in both to show you that you do indeed get the same answer no matter which one you decide to use. So this answer is approximately 1.5283. Now keep in mind what that means. That means if we take the number 8 and we raise it to the power 1.5283, we're going to get approximately 24. So this allows us to be able to find the power of any number to get any other number. For our last example, suppose that the population in a small city is 32,000 in the beginning of 2010, and that the city council assumes that the population size t years later can be estimated by the equation p equals 32,000 times e to the 0.05 times t. The question is, approximately when will the city have a population of 50,000 people? So when is P going to equal 50,000? At what time does that happen? So to do this, I'm just going to plug in 50,000 for P. So that's going to be equal to 32,000 times e to the 0.05 t. From here, we can divide both sides by 32,000. These are going to cancel out. Now, 50,000 divided by 32,000 is the same as 25 over 16. Okay, so what I did there is I just reduced the fraction. What you could do there is you could type in a decimal if you want. That would be okay. And this is equal to e to the 0.05 times t. Now, to solve for t, I'm just going to take the natural log of the left side, and that should be equal to the natural log of the right side. And this allows us to bring this power down. So we have the natural log of 25 over 16 is equal to 0.05 t times the natural log of e. Now keep in mind the natural log of e is 1, so this basically just cancels out. And then to solve this, I'm just going to divide both sides by 0.05. So in the end here, we get t is equal to the natural log of 25 over 16 divided by 0.05. And this gives us an answer of approximately 8.9 years. So this means that in this small town, in 8.9 years, we can expect the population, which is currently 32,000, to grow to 50,000. Now, it does say approximately when will the city have this population. So if you remember, this started in the year 2010. So in 8.9 years, that's going to be 2018, right? It's going to be later in 2018. So you can either give the answer as a number of years, which is typically how we do it, or you can say exactly when that's going to happen by taking into consideration that the beginning of this problem was in the year 2010. And of course, this would be assuming that we were talking about January 1st of 2010. Okay, so yeah, it's probably better just to give the answer as a unit of time rather than try to nail down the specific year. But sometimes you'll see answers given in both ways. And that concludes this video lesson.